we did this last time where the probability distribution was probability of x equals to k was given as 1 minus p to k minus 1, so that when this is success when you get to k. So if this k is 3, that means you've done a Bernoulli trial and the first 2 was unsuccessful and then the third one was successful. So the last one was successful. That was the formula I presented for the geometric distribution. And I made the comment that expectation of x is equal to 1 over p. I want to show you this as a proof. I want to prove this because then you'll see the geometric series in action and you'll see where the naming comes from. Okay? Alright, so let's actually prove this. So E of x is summation of xi pi, but the values that this x can take are values from 1 through infinity. So you have summation of k goes from 1 through infinity. And the probability that x will be equal to k is exactly this, right? So instead of pi, we're going to use this formula here. We're going to put 1 minus p, k minus 1 times p. Now I'm going to do one more thing. It's customary to use q for 1 minus p. Especially when you write down the binomial probability, you say q is equal to 1 minus p. And that's the probability of an unsuccessful outcome. Okay? So Bernoulli trial is like one trial where the outcome could be successful or unsuccessful. P is the probability that it would come up as successful. This will be the unsuccessful probability. Okay, at first, let's just see what this is. Rather than writing it here, let me just quickly write it down to see what it's like. It's like 1 times q to the 0th power p plus 2 times q to the 1st power p plus 3 times q to the 2nd power p, 4 times q to the 3rd power p, and then so on and so on. This is the infinite series that you're trying to figure out, okay? Right. Now we're going to use some calculus. And the way we're going to use calculus is by saying that if you have x to the nth power, what's the derivative? Hopefully that you didn't forget.
N minus 1.
Yeah. So it's a rather easy one. So I'm going to replace n by k, and seeing that this is exactly the same format as this, we're going to do the following. I'm going to say that if you take x to the k and differentiate, and then you evaluate x at q. So this symbol means you plug in whatever that's in here, okay? So we just differentiate and plug it into q. So you're evaluating the derivative, right? If you do that, you recover this entirely. And furthermore, I like the fact that p doesn't have any k in there. This is a constant, so I can pull this out. So Same trick. So let's now write down what this one is. Actually, you can even bring the derivative outside. So like this, okay? So we just have to figure out what this function is, and then differentiate, and then put p. Okay, what's this? That's easier. If k is 1, that's x. K is 2, you get? What do you get if k is 2? X squared. The summation just means you keep increasing the k value and plugging it in, okay, one by one. So the next one, x cubed, x to the 4th, so on, so right. Now, I'm going to make this slightly easier by adding a 1. And that doesn't really hurt this. I can replace this thing by this one because 1, if you differentiate, goes to 0 anyways, right? So I'm just going to rewrite this to start from 0, x to the 0th power is 1, and it's still the same thing. All right. Now the question is, what is this thing called? Do you know what this
Power
is?
series.
Huh?
Power series?
Okay, so it is a power series, but it's a very specific type of power series. To advance to the next term, you only multiply by x. So you have a common ratio. What is that called? If you have a series where every term, every successive term is some constant multiple of the previous one, what is that called? No? Geometric. That's the correct word. Okay, this is the geometric series. It's a geometric series with the initial value a equals to 1 and common ratio x. Does anyone recall the formula for the geometric series?
Isn't it like
A over one minus okay. Minus r. I just realized some of you don't learn this in Calc 2. You just glance over it. Right? When I teach Calc 2, I really teach this. Some, right? Yeah, you remember this? Okay, good. All right. So, so that's the formula, which says it should be A is 1 and 1 minus R, common ratio R is X. So this is equal to that. Now, if you don't know this, it's fine. You can still figure this out. Just do this. Set this as the sum. S is the sum of all these things. Multiply by X. Actually, multiply by X. Okay. What is 1 times X?
x?
X. What's X times X?
X squared.
X squared. What's X squared times X? X cubed. So if you multiply to S the X, you get very similar things. Now try this. Subtract. What happens?
We should get 1.
1 minus X times S is equal to, everything here cancels. What's left?
1.
1. So what's S? 1 over 1 minus X. Magic, right? Okay, so that's what you have. And what this formula is saying is, now we have it. So now let's just continue on. What does this mean? It means that all I have to do is take this thing, 1 over 1 minus X, or rather, 1 minus X to the negative 1 power. That's easier to differentiate, right? So I'm just rewriting this as 1 minus X to the negative 1 power. Differentiate and plug in X equals to Q, and that's it. That will be this horrible looking sum. Alright, so let's see what happens. Negative 1 comes out, 1 minus X, subtract 1, that's negative 2, and then you plug in Q, that's negative P, 1 minus Q, let's do negative 2. Okay, if q is 1 minus p, then can you solve this for p? You can move the p over here and q there. What's p equal to? 1 minus q. So this one is really p. So what you have is, sorry. This derivative is wrong. There's a plus 1, right? Where do you get the plus from? Chain rule. Yeah. 1 minus x has to be pulled out and differentiate. That gives you negative 1 as a chain rule. So this should be this. And what that gives us is that it's p over p squared, which is 1 over p. I'm all over the place, sorry. So that's the final answer, 1 over p. Done. Yeah, so we were able to prove this, and along the way, what did we have to use? The geometric series. That's where the name geometric distribution comes from. Now, a challenge I want to give to you, which has nothing to do with exam 1. You can do this if you like what you see and deepen your understanding. So another challenge you might do is to try to find e of x squared. And to do that, all you have to do is differentiate this one more time. If you think about the second derivative, actually, instead of this, if you differentiate twice, then it's easier to get x minus 1. Because if you differentiate this once, you get k, but if you differentiate again, k minus 1 comes out, right? So that's like x times x minus 1. So you can calculate this. If you calculate this, this is just simply e of x squared minus x. So that's going to be e of x squared minus e of x. So using this, you can recover what this is. If you know what this is, then you can find the variance by using the formula that v is equal to e of x squared minus e of x squared. Okay? So you can use this to figure it out.